All right, guys, this is the study guide key. Ignore that it says accelerated chemistry. That was just what my last class was called. So this is our Unit 1 study guide. First thing we're looking over, I'm just going to go through a brief run through of this, and really I want to get to the math stuff, so I'm going to go through this part pretty quick because this is all in your notes. All right, the difference between pure and applied chemistry. We said that pure chemistry, I told you in my notes that it was chemistry for its own sake. Another way you can say it is pure chemistry is the study of chemistry for a theoretical purpose. There's no problem to solve. It's just, I'm doing it because I feel like doing it. And an example is something like Brownian motion, which we'll explain that when we talk about the history of the atom. Versus applied chemistry is the study of chemistry to solve a specific problem or question. An example is changing a light bulb that went out, just like we did in the scientific method. Number 2 is your choice. Number 3, it is important that you follow these directions. Your answer should look like this for all of them. All right, so there's going to be a full sentence in there. Physical chem is used when determining the energy transfer when water boils, because physical chemistry is the study of energy transfer, rate, and mechanisms. I want to drill those 5 types in. All right, we're missing one type, and you should be able to identify that type as inorganic chemistry right there. The algebra review, this is what I really wanted to get to, and on my key it's written a little bit differently, but hopefully on your guys's I spaced it out so you knew that this was not attached. This is actually telling you solve the problem 2 times 4 plus x if x equals 1. So hopefully I separated out. So that means that this x right here is actually 1. So I could simply replace it just like I've done right here. And when we do that, I do what's called distributing. So you can solve this one of 2 ways. I can do 4 plus 1, and that's 5. And then 2 times 5, or is it minus 1? Oh, no, sorry. Yes, we're going to distribute the 2 in just like I did over here. So 2 times 4 and 2 times 1. And we get 8 plus 2. I don't know why I did 8 plus 1 over here. 2. That's 10. And then the answer is 10. Or you could have done it the other way like we said, where you could have done 4 plus 1 is 5. 5 times 2 is still 10. So the same for these. This is saying that this x is 4. So I would have something that looks like this. I could distribute through, or I could do 6 times 8, which is still 48. Same thing. Now I just have minus. 15 minus 2 is 13. Times 9 is 117. Or I distribute that 9 through. Okay? Doing some scientific and standard notation. These are extremely important. This 654,000. This decimal is moving that direction to make that 6.54. So if I take that 6.54 times 10 to the 5th, and I want to change it back into 654,000, I would need to move that decimal back this way 5 times. That's why it's a positive 5. Notice this number right here was 0.000. It's way small. It's smaller than 1. So if I want to turn this number back into that 0.000 number, I would need to move the decimal that direction. That's why it's negative 7. So this one I have to move positive. When we do that and we write the following in decimal form or standard form, that positive 5 means that I move it this way. That's why we got a really big number. That negative 6 means we move it this way. That's why we got a really small number. That 4, move it that way, which is why we got a bigger number. Positive numbers, you have to move them in the positive direction. Negative numbers, you move in the negative direction. All right. Adding and subtracting, multiplying and dividing these numbers that are in scientific notation. I want us to practice putting these in your calculator. Then you have no problem. All right, there are rules to doing this, but we're going to put it in our calculator every time. So everyone get your calculator out. pause this video and then get your calculator out and then start the video again. All right, now that you have your calculator, okay, I want you to type in this number. Oops. We're going to type in that number, 3.5 times 10 to the fourth. Don't do it yet. Do it with me. So how we're going to put that in your calculator, you're going to put the number first. Type in 3.5. Then you need to find the button that says EE. EE. All right, mine is blue, which means I have to push the second button to get to it. So next, I'm going to push second, which is a little button on the top left, and I'm going to push EE. Those two numbers, when I do that, that means times 10. Then, fourth and last, I'm going to put 4 because it's raised to the fourth power right here. I'm going to put 4. My number in my calculator should look like this, 3.5E4. That's the same thing as saying 3.5 times 10 to the fourth. But what it does is eliminates our order of operations. I don't have to use parentheses when I use this. All right, if I was typing that in my calculator and I was putting in 3.5 multiplied by 10 with a little caret raised to the fourth, you're going to have to use parentheses. I don't want you guys to have to do that, so please do it my way. It makes it so much easier. So now when you do this problem, I'm going to type in 3.5 second EE 4 plus 4.1 second EE 3, and you will get 3.91 times 10 to the fourth. You will get this answer. Let me try it so I didn't just lie to you. 3.5 second EE 4 plus 4.1 second EE 3. I got 39,100, which is the same exact thing. If I take that decimal, whoops, 100. If I take that decimal and I go 1, 2, 3, 4, I would have 3.91 times 10 to the fourth. Same exact number. You got the right answer. All right, if we do 17, I want us to type it in. Follow me. 7.2 second EE negative 6 minus 8.2 second EE negative 7. You will get 6.38 times 10 to the negative 6. It will say it like this. It's perfectly fine. Same number. All right? But that's how we type these into our calculator. Do it every time. If you do it the other way, eventually you're going to mess up, and it'll probably be on 18 and 19. But if you do 18 and 19, you will get the same exact answer. All right? Moving forward to rearranging these equations, let's walk through this first equation right here. This is the same thing as me writing D equals M over V. D is density, M is mass, V is volume in this equation. We'll just say D, M, and V. It says to solve the equation for M. So that means that we don't know what M is. So let me put some numbers in so we can make it more real. Let's say that D is 10, M we don't know, and V is 2. So it's just like this. How do we get 2 off the bottom of the fraction? That's extremely important. You multiply both sides by 2 because the number is 2. When I do that, it's going to cancel these out because 2 times 2, or 2 divided by 2 is 1. So it cancels it out and moves it to this side. Now, I've got 2 times 10 equals M. 2 times 10 is 20. 20 equals M. That's how we would solve for M. That's exactly what I did right there. All right, let's try 21. I'm going to do it in green. I've got now PV equals nRT, another equation that we're going to use this year, all variables right now. We want to solve it for P. So this is like saying I don't know what P is, but I know what all the other ones are. So if I just look at it with no numbers, to get P by itself, I simply have to divide both sides by V. That's going to cancel V out over here. right? And leave me with P equals nRT over V. Exactly what I did right there. Now let's try 24, where we enter in some numbers. I'm going to erase this. No, I'll just write small. Let's go with blue. So now it tells me I've got PV equals nRT, and V, I do not know what P is. V is 20. I'm going to use parentheses around here just so I know what's what. N is 5. R is 0.821. And T, move this over a little, T is 298. All right, so now we've got numbers. So if I actually want to solve for what P is, let's do the same exact thing. Let me go ahead and divide by 20. When I do that, it cancels out. I'm left with P equals 5 times 0.821 times 298 all over 20. This, we can plug that into our calculator. So I'm going to plug it in like this. I'm going to go 5 times 8.21 times 298. I'm going to push, I don't like that. Oh, I put 8.2 in, that's why. 5 times 0.821 times 298 equals divided by 20. Now, I just want to try it to see if it messes it up if I don't push equals after I do all that multiplication. 0.5 times 0.821 times 298 divided by 20. Yeah, I get, see, if you put it all in at once, it messes up your order of operations. So after I do this section, I'm going to push equals, which is going to say, now P equals 1223.29 all over 20. Now do 1223.9 or 0.29 divided by 20. You should get that number right there. That's exactly what I did. All right, make sure that we know this stuff. If you don't, email me. We can get together during office hours and we can figure this stuff out, okay? Last is this, it says 7, this should say 6. 6 steps to the scientific method. So I crossed all this out. Our independent variables, dependent variables, short story goes down here. And we're done. All right, let me know if you have any questions on these written ones, but I wanted to go through some examples on these math ones.